Good evening, everyone. I'm Neelam Parshuram from IC Ventures team. I hope my voice is audible. Warm welcome to all of you. Thank you for joining us once again this Tuesday. For those who are attending this for the first time, welcome to our weekly industry webinar series, where every Tuesday we connect professionals, experts, and learners from elevator and escalator industry to one common platform. While we wait for a few more participants to join in, I'll take a couple of minutes to share what does IC do and how do we work with the industry. So IC platform is designed to share practical knowledge, industry insights, and real world experience that can help you grow professionally and stay updated with the latest development in the industry. We are glad to see participants joining in from the different location, and we truly appreciate you taking time out of your busy schedule to learn, gain insights, and upgrade your knowledge with us today. So this is an initiative by IC Ventus. IC Ventus also organizes exhibitions, trade shows, and industry events. We create platforms that support learning, collaboration, and business growth. IC Ventus has become a trusted bridge connecting regional market with global opportunities. Our upcoming shows, first is IC India 2026, will be held on 3rd, 4th, and 5th December in Delhi, proudly making the capital city the host of this year's edition. With a strong industry support, IC has grown into the world's fourth largest exhibition for escalators and elevators, reflecting the trust and collaboration of the entire industry. This year's expo is planned across a massive area of 40,000 square meter, featuring 350 plus exhibitors, making it one of the largest gathering of the vertical transportation industry in India. So get ready and plan your visit accordingly. We recommend you at least to plan for 2 days visit to experience the scale of this expo. Our next show. So building the momentum, we proudly announce the the Monsoon edition in Chennai, featuring the quiz, symposium, and a dynamic industry expo scheduled for 5th, 6th, and 7th, 2027 in August. The Chennai edition reflects Chennai weather calendar held before monsoon season. It creates a perfect time for the industrial professionals to network, plan upcoming projects, and discuss solution before the operations slows down, typically caused because of heavy rains. Our next show is IC Africa 2027. Will be held from 24th, 25th, and 26th November, November at KICC, Nairobi. As you may know, Kenya is emerging as one of the fastest growing market in Africa for infrastructure and urban development, creating a significant opportunity for elevator and escalator industry. In this context, I see Africa 2027 will bring together global manufacturers, suppliers, and industry leaders to showcase safe, innovative, and sustainable vertical mobility solution and drive growth across Africa's vertical transportation sector. Moving on to our today's session, we are delighted to have Ms. Deepika Jagdale, Assistant Manager, Escalator Section, Research and Development from Research and Development team at Schindler India. With the over 5 years of experience in design and development, she began her career at Bharat Forge and Expert Global Group, and now works on developing innovative escalator solutions at Schindler India. She will be presenting on energy efficient escalators at tourist attraction, where she will share the insights of the necessity of escalators in high altitude mountain region and approaches to improve energy efficiency at the special application for the special applications. This is a great example to see how innovation in engineering is solving real world challenges. With that, I would like to hand over the session to Ms. Deepika. Over to you.
So Neelam, first of all, thank you for the wonderful introduction. So I begin my session. I'll share my screen. Is my screen visible?
Yes, we can see your screen.
Okay, fine. So today's topic, energy efficient escalators at tourist attractions. Imagine that you plan to travel to Jaipur Temple in Shimla along with your family. You start your trip by going to a metro station. You take one step on the escalator and reach up to your train. Next, when you reach to the airport, you take one step on the escalator and reach up to your plane. When you reach at your destination place in Shimla, at the base of the mountain, you take one step on the escalator and reach to the peak of the mountain at the doorstep of the temple. So, you traveled along with your old age parents, your small kids, your pregnant wife, your disabled cousin, and you had a smooth, convenient, quick, economical, and ergonomical journey by using escalator to reach the peak of the mountain over traditional means of transportation like the cable car ride, the helicopter ride, the trek ride, or the animal ride. These escalators, which are installed in the mountains, have large vertical rise, have high passenger carrying capacity. They have a they are installed in pairs. They have a double drive. Double drive means they have two motors, two gearboxes, two brake units, and they consume high amount of electricity. In this presentation further, we will discuss the parameters which affect the electricity consumption of escalators and the methodologies to improve the energy efficiency in escalators. So, the total electricity consumption in escalators is a sum of fixed energy consumption and variable energy consumption. So, fixed energy consumption. It is the amount of energy required to run an empty escalator without passengers. Means it is the amount of energy required to overcome the friction in the movement of the handrails and in the movement of the steps. And it depends upon the selection of components, mechanical components, which are responsible for the movement. That is, for example, bearings, guiding systems, and gearbox. In the slide, we see an example where when we use ball bearings over plain bearings for the handrail movement or for the step chain rollers, and if we use wheel guidance systems over chain guidance systems for the step chain rollers, and if we use an involute type of gearbox, which is spur or helical gearbox having line contact over cavex gearbox, which is a worm gearbox having surface contact, the amount of friction is very less, and hence the amount of fixed energy consumption is very less to drive the handrail and to drive the step chain. Variable energy consumption. It is the amount of energy required to move the total number of passengers along with their weight in the direction of vertical travel against the gravitational force, taking into consideration also the walking factor. The walking factor is that some passengers do not stand still on the escalator, but they walk or run on the escalators, and hence the amount of energy required in this situation for the escalator is less compared to the normal situation. So the first methodology for energy efficiency is that the escalators are powered by wind turbines and by solar panels. So the wind flow in the mountain areas is constant, is stable, and and the wind speed is very large due to there is not due to the non-disturbance from high altitude regions in the city areas. So this allows the wind turbines to perform more efficiently or with maximum efficiency to generate electricity, which can be used to power the escalator. So the, the total power generated by a single wind turbine it depends upon the density of air. It depends upon the cube of the wind speed. It depends upon the swept area of the blades. While the efficiency of the blades depends upon the actual power captured by the blades to the available total wind power. And the total energy efficiency or total energy generated by the setup also depends upon the efficiency of the gearbox and efficiency of the generator. Next, escalators powered by solar panels. So, at the peak of the mountains, the solar energy is less scattered, it is direct, more intense, and the cooler atmosphere at the mountains also help to reduce the thermal losses in the solar panels, making them perfect or ideal for developing maximum efficiency to generate electricity required to power the escalators. The setup we can see consists of the solar panels, the inverter, which converts the DC power from the solar to the AC power, which is then this power is stored into the battery whenever required, and this power is then supplied from the battery to the motor of the escalator. The parameters that affect the power generated by the solar panel depends upon the area of the solar panel, the efficiency of the solar panel, the total radiation on the tilted solar panel, and the coefficient of losses, that is the losses from the gearboxes or the losses from the generator. Solar panels can also be installed at the roof of the escalator tunnels and the outdoor applications. This will give dual advantage. First, the safety of the passengers from the escalator tunnels, and also the maximum space utilization. Otherwise, the solar panels need to be installed in the open ground, as shown in the picture below. So, the solar panels and the wind turbines can also be used together as a setup wherever required for maximum energy generation. This will help to completely reduce the dependency on the main electricity grid, and which will help to achieve zero electricity bills. The next, number two, the next type of the system for energy efficiency is by using a smart control system. Means what? That installing a variable frequency drive along with a regenerator in the control unit of the escalator. Imagine, so first is the variable frequency drive. When we install a variable frequency drive in an escalator, it will help to achieve, it will stop the motor when there is no passenger traveling on the escalator. It will when it sense the passenger coming towards the escalator, it will allow smooth starting of the escalator. And when the passenger is departing from the escalator, it will allow smooth stopping of the escalator. So the escalator motor or the escalator is only functioning when passengers are available or traveling on the escalator, and otherwise there is no consumption of electricity in the absence of passengers. This is the first method achieved with the help of the variable frequency drive energy saving methodology logic. The second step that we use is that that imagine a small kid playing on a slider, so shown in the picture below. So when he's moving up on the slider against gravity, he requires large amount of energy. But when he's sliding down from the slider towards gravity, very less amount of energy is required. Same thing happens for the escalator. When the escalator carries the passengers in the upward direction, it requires large amount of energy. More the passenger, more the weight, it requires more energy to move the passengers in the upward direction. When it moves the passengers in the downward direction towards gravity, it requires very less amount of energy. The more the passengers, the less amount of energy is required to drive the escalator in the downward direction. But in both the cases, whether the escalator is moving in the upward direction or whether it is moving in the downward direction, the amount of power supplied by the motor is same. So at the motor, this extra amount of power is collected, which is more than that is required. This extra power, which is collected at the motor, is otherwise dissipated in the form of heat by using a braking resistor. But when we install a regenerator, this extra power at the motor is sent back to the grid. So the power is not wasted, but in the downward moving in escalator, in a high capacity downward moving escalator, this power is generated and it is sent back to the grid. So where is this VFD or and along with the regenerator situated in an escalator? So as you can see from the picture, it is situated before the motor. So let's see the diagrammatic representation. So this is three-phase. This is three-phase supply from the grid. This three-phase supply is AC supply, and this this power is sent from the three-phase AC supply. It is sent to the diodes rectifier. What does it do? It converts the AC to the DC, and and it allows the current to flow only in one single direction. Why AC to DC? Let's see. And now this DC, it is stored in this capacitor. This DC energy, DC current is stored in this DC bus or DC capacitor. This DC is again converted to the AC, but this AC is now controlled frequency and controlled voltage AC. Why controlled frequency and controlled voltage AC? Based on the number of passengers. It means it does not have to every time run the escalator, but the escalator will only run based on the sensing of the passengers. So controlled frequency and controlled voltage AC current to convert AC from the fixed voltage and fixed frequency voltage to controlled frequency and controlled voltage AC. We have to convert it to the DC, and this AC to DC is converted by this diode rectifier, and this DC is stored as a store bank in the capacitor or a DC bus. So this is when the escalator is consuming power, that is in the upward moving escalator. Now, in the downward moving escalator, the extra power which is collected at the motor, because for just consider that passengers requires less energy to come down from the stairs, but if someone pushes him, so he will run fast, he will be pushed with a more force in a downward direction, so this energy is more than what is required. Similar happens to the motor. The motor has more energy than it requires, so this extra AC power collected at the motor is then again converted to the DC with the help of this inverter. This inverter, it converts AC to DC or DC to AC. It is again converted to the this AC is converted to the DC and it is stored in the DC bus link. And from DC, it is again converted to the AC, but it is again controlled voltage and controlled frequency as per the requirement of the grid, and it is sent back to the grid. It is sent back to the grid. Grid. The fuse helps to protect from excess current, while the reactors that we see, they help to reduce the harmonics, or they help to reduce the unwanted frequencies in the system to allow the smooth flow of the current. So in this way, the first method helps to save the energy when not required, and the second method helps to generate energy which otherwise would have been dissipated in the form of heat. Now, we saw here that there was a diode rectifier which allows the current to flow in one direction. So if we connect this directly over here, so what we get a variable frequency drive with sinusoidal PWM converter. So this setup is exactly similar to this setup, but with the difference that this is connected over here at the top.
Deepika madam, excuse.
Yes.
Actually, there is one comment that your voice is echoing,
Okay.
and can you like go a bit slower?
Sure.
Thank you.
Okay. Sure. Thank you. Okay. So here, this is a sinusoidal PWM converter. This is also a regenerator, but but it has some additional advantages. So in the here we have the variable frequency drive, and before the variable frequency drive, there instead of the diode, we have again you see the same picture to the left as well. So this allows the current to flow in both direction, means from left to right and from right side to the left hand side. So this is also called as an active front end controller. So this is again a regenerator. It generates energy in a downward moving escalator, but it also has some additional advantage. The current the current which is from the taken from the grid is converted to the pure sine wave that you see, a smooth sine wave, uh, which otherwise would have is in the form of a distorted form. This pure sine wave will help will help to improve the life of the electrical components. It will help to reduce the heating of the electrical components, and it will help to have the consistency with the grid, with the current grid. So it also helps to achieve a power factor is equals to 1, and it allows the bidirectional current flow. So the functioning is again similar. So I do not explain, but additional advantages like the power factor as 1. It works. It improves the. It has a very good improved supply power quality, and the total harmonic distortion is less than 5%. It has very less harmonics, means unwanted frequencies. And since the total unwanted frequencies is very less, the total harmonic distortion is less than 5%, and hence the power supply is of very improved quality. This is installed in the downward moving escalator, giving advantage of a regenerator along with the improved supply power quality. This is also installed in the upward moving escalator to to the because of the additional advantages of the improved life of equipments, electrical equipments, to achieve the power factor as 1 and to have an improved supply power quality. So this is the latest version. Coming to the conclusion, we see that escalators form a very important application to reach the peak of the mountain areas in the tourist places. These escalators can be efficiently powered with the help of wind turbine or solar panels, which perform efficiently in the mountain areas. These escalators, as you see, are installed in pairs in the tourist places. An upward moving escalator consumes power, while a downward moving escalator generates power. This escalators can so with the help of a sinusoidal PWM converter, we can also have an improved supply power quality along with the regeneration capacity. And when installed together, that is solar power panel, solar power or wind turbine, when installed together with the regenerator or with the sinusoidal converter, will help to give the maximum efficiency in escalators. So we see here some examples. The escalators are already installed at Jaku Temple in Shimla. They're installed at Ocean Park in Hong Kong. They are in the phase of installation at Batu Caves in Malaysia, at Mount Titlis in Europe, also Vaishnav Devi Temple in Jammu. So this is from all from my side. Thank you very much.
Thank you, Deepika madam, for sharing the information. We truly appreciate your time. Is there any questions on this? Please, attendees, you can put it down in the Q&A box. Any questions from attendees? There's one question from Mr. Ronald. Thank, thanks a lot for the presentation. One question, is the power generated consumed immediately or stored?
Uh, if we are using batteries, we can store the power. If we are not using batteries, but if we are sending power to the grid, so it can be used later. So there are two options. Either we connect it to the battery, or we connect it to the grid, main grid.
He's saying greetings from EBCon.
Yes.
One more question from Mr. Ronald. Which one is the common practice?
To send back to the grid. There is one more misunderstanding maybe people have, that in upward moving escalator we consume power, and in downward moving escalator we generate power. So can this generated power can directly be consumed in the downward moving escalator? So no, it is not this way. The power is sent back to the grid.
I hope uh, Mr. Ronald are satisfied with his question. Ronald sir is saying thank you. Thank you, Deepika ma'am. Another question from Mr. Ravi. Are the regenerative type drives certainly reliable when compared to non-regen type? Are they a long-lasting regen type? Deepika ma'am, can you see the questions?
Okay, 1 second, let me see.
Maybe you can here at the bottom. Can you see the options? Bottom side.
Yes.
There is Q&A button here.
Yes, correct.
Yes, yes, yes.
Are the regenerative type drives certainly reliable when compared to non-regenerative type and the long-lasting regenerative type? Yes. So the regenerative types are long-lasting. They are very efficient, but only when they're in the applications where in the downward moving escalators, it runs with a high capacity. Means the downward moving escalator is loaded with full capacity passengers, and it is used industries, it is used in many applications or many escalators nowadays, but only a disadvantage that it is costly, and it requires complex study, or the complex control unit analysis.
Is there any other question on this topic? Deepika ma'am, I think so. There is no other questions for now from the audience. In case attendees, if you have any question in future, you can connect with Deepika madam later after the session for the questions. I thank you, Deepika madam, for sharing the information. Really appreciate you taking time for sharing the knowledge and your expertise with our audience today. And I also thanks to all our audience who are joining and who have been present here. It means a lot to us, and it truly motivates us to continue organizing such knowledge sharing initiatives for the industry. Since it's a financial year ending today, I know many of you might be busy in closing numbers and accounts. I really thank you for taking time out and joining us today. As a reminder, I'll tell you that this webinar happens every Tuesday. Our next session will be on 7th April. Thank you for joining today once again.
So thank you, Neelam, for giving this opportunity, and thank you, Schindler, for giving this opportunity. Thank you, ISE, as well.
Thank you, audience. Thank you, Deepika madam. We'll stay connected.
Thank you.